Orbital manufacturing is still in its early stages. We already have a few real-world examples. Arkisys has successfully grown pharmaceutical crystals in microgravity, and SpaceForge has demonstrated a high-temperature furnace operating at 1000 degrees Celsius. In addition, the International Space Station hosts payloads for 3D printing, crystal growth experiments, and a wide range of other manufacturing research. Today, I want to make the case for 4 tiers of orbital manufacturing. We already have 2, small capsules, such as those used by VADA, and large human-tended space stations like the ISS. I will introduce 2 additional tiers that I believe are essential but do not exist yet. These 4 tiers create a much smoother progression for space startups, starting with small, low-risk payload experiments and scaling up to a larger, more sophisticated manufacturing operations in orbit. At the end, I'll tie up these 4 tiers and give my opinion on the current state of orbital manufacturing. As always, please drop your thoughts and opinions in the comments section after watching the video, and we can discuss at the weekly livestream on Saturday. Okay, let's get started with Tier 1. Tier 1 Capsules. This is the simplest and cheapest method of manufacturing in space. Examples include VADA Space, which has launched 4 re-entry vehicles into orbit so far. These capsules spend months in orbit producing pharmaceutical products in the near-perfect microgravity environment, creating exceptionally pure crystals without the sedimentation and impurities that happens under Earth conditions. After the manufacturing process is completed, the capsule is deorbited and lands softly back on Earth. VADA Space is ramping up its operations to provide a high-cadence service in the future. Other startups are focusing on the production of superalloys and purer forms of silicon for semiconductors. One such example is SpaceForge. Last year, they demonstrated for the first time ever operating a furnace in space, reaching a temperature of 1000 degrees Celsius. This tier provides support only for small payloads, typically in the tens of kilos range. This is more than enough for high-value pharmaceuticals, where typically only tiny amounts are needed for medicines. The primary users of this tier are startups at the proof-of-concept phase. They're evaluating the cost versus the benefits of orbital manufacturing. Each flight provides an opportunity for improvement of the manufacturing process without a huge expenditure, at least in comparison to other alternatives. The downside is it's not possible to manufacture at scale. This Tier 1 facility works better for pharmaceuticals than metal alloys or ultra-pure silicon wafers. Okay, let's move on to a missing link in the orbital manufacturing sector. Tier 2 Orbital Manufacturing Stations. In this second tier, a permanent orbital platform is deployed. This facility supports multiple docking ports for visiting vehicles. The orbiting platform could, in a basic form, consist of a long metal truss with solar panels and radiators for power and cooling. The facility would provide communications, electrical power, thermal management, and other common functions. While this tier of orbital manufacturing doesn't exist yet, it could in the near future. In fact, a new startup called Dispatch has exactly this concept and has received funding of $500,000 as a Y Combinator-backed startup. Their concept is an uncrewed orbital manufacturing station in low Earth orbit, paired with in-house designed re-entry vehicles similar to VADA Space's capsules. The platform performs factory-like operations with no support from humans. Their subscale re-entry vehicle starts with a 30-kilo payload with a 2027 demo planned. A future version of their re-entry vehicle supports payloads of up to 300 kilos. Their orbital platform provides a total of 100 kilowatts of power, with Dispatch targeting deployment for late 2029. Here is a quote from CEO Peyton Case. The whole premise is, if you're going to be manufacturing in space at scale, why launch the factory every single time? Just have delivery trucks take things there and back, unquote. He also noted that future in-space manufacturing will not involve people to avoid the high costs of crew-rated systems. Advantages of a persistent orbital platform is that the re-entry capsules can be simplified, stripping out much of the tech needed for power, cooling and communications and moving that to the orbital platform. For instance, Perhaps solar panels can be removed or reduced in size and replaced with a battery. After arrival and docking at the facility, the vehicle receives access to power, thermal management, and communication systems. The company pays for the amount of time the vehicle is attached to the docking port and usage fees for platform services. Manufacturing needs to be fully self-contained within the visiting vehicles, which limits the sophistication of the manufacturing process. Dispatch isn't the only startup pursuing the idea of orbital platforms in space. Arkisys has a concept called the Port. They describe it as a scalable robotic space infrastructure platform. The platform supports in-orbit payload testing, assembly, manufacturing, and upgrades. Arkisys expects the platform will grow to orbital factories, autonomous infrastructure, and scalable deep space operations. Arkisys provides port services for visiting vehicles, including refueling, recharging, and upgrading. They envision offering battery swaps, replacing depleted batteries with fresh batteries charged up at the port. Port modules can be chained together to grow the platform. The port isn't limited to low Earth orbit. A station located at L1, a balance point between the Earth and the Moon, would allow easy station keeping and support craft heading to or from the Moon. Let's look at a more sophisticated manufacturing facility next. Tier 3. Robotic-Tended space stations. Think of these stations as similar to human-tended stations like the ISS, but with all the life support and other systems needed for humans stripped out. It's possible these stations could be operated in a vacuum as well. Robots, either humanoid like Tesla Optimus or simpler versions, could be used both inside and outside the facility. Robots could be used to help perform, monitor, and operate the equipment to support manufacturing operations, something that is not possible with the low-tier facilities. For instance, NASA has developed the Astro B, a free-flying robotic system for use inside the ISS. Arkisys has a contract with NASA to sustain and maintain this robotic platform. Icarus Robotics, another space robotics startup, is working on replacing humans with robots for routine tasks, such as cargo loading and unloading. This New York startup has plans, in partnership with Voyager Technologies, to deploy a free-flying robot on board the ISS in 2027. Their robot has 2 manipulator arms to move things around, and uses fans to fly, similar to how a submarine maneuvers in water. Icarus will start by teleoperating the robot, switching to a fully autonomous version later on. Gitai, originally a Japanese startup but now located in the US, builds robotic arms for use in space. In particular, their inchworm robotic arm would be perfect for orbital platforms in both Tier 2 and Tier 3 facilities. Multi-step manufacturing operations are possible, with robots used to move intermediate products from one piece of equipment to the next, eventually producing the finished product, which can then be packed and sent back to Earth on the next supply vehicle. These stations could be outfitted with a docking port for astronauts to enable repairing, upgrading, or outfitting of the station with additional equipment. The astronauts would need to stay in their spacesuits if the station was operated in a vacuum. Humans visiting the facility would be an exception, as these kinds of stations are designed to operate without human intervention. This tier bridges the gap between self-contained, small-scale manufacturing and the massive expense of human assistance in orbital manufacturing. An astronaut's time costs $130,000 per hour, plus the cost of using ISS facilities. And finally, the last tier. Tier 4. Human-Tended Space Stations. We're all probably familiar with this tier, which is represented by the International Space Station and China's Tiangong facility. These stations are designed for the permanent presence of humans and come with life support systems, thermal control for humans, and space for consumables, food and water needed to keep humans alive. These stations are very expensive, with NASA spending between $3 to $4 billion every year to support the ISS. As mentioned already, astronauts who are paid $130,000 per hour spend most of their time unloading cargo from resupply vehicles or packing equipment for return to Earth or orbital disposal. It's likely NASA will lose access to its human-tended station in the near future, as their focus is now on building and operating a base on the surface of the moon. Final thoughts. The step up from basic capsule manufacturing, as demonstrated by Vada Space, to payloads running on the International Space Station is huge. The amount of paperwork needed to get approval to send a payload to ISS is significant, with many years passing between application and flight. This harms startups, which need to move quickly to succeed in the market before running out of funding. The more options startups have to test and validate manufacturing in space, the more likely some of these startups will succeed. Orbital manufacturing is most likely to provide immediate benefits for pharmaceuticals, novel materials, super alloys, and other areas. Tier 2 and Tier 3 are similar, with Tier 2 representing the next step, a basic orbital truss with attachment points for visiting vehicles. There is no or only limited robotic support, with a Gitai inchworm robot for berthing or battery swap operations. Tier 3 represents a more substantial station or platform, with robotic support for multi-step manufacturing operations. This facility could operate in a vacuum, with temperatures more suited for manufacturing rather than human comfort. What do you think of these 4 tiers of orbital manufacturing? Do you think Dispatch's concept of an orbital platform with multiple factory capsules is a good idea? Leave your thoughts and opinions in the comments section below. Thanks for watching. If you enjoyed this space video, consider buying me a coffee to help fund more episodes like this. The link is in the description. Watch the weekly live stream to see the images, clips and slides from this week's videos. It's a live Q&A on this week's space topics where I read out some of the best comments. The more people join, the more fun the live stream is. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.